Hi, and welcome back to Lipids. We are in our first type of lipid. We're studying fats right now. We just finished on constructing one fat molecule, which is called a triglyceride. You have one glycerol, a 3-carbon chain, and you add 3 fatty acids to that glycerol, and now you have a triglyceride. Now let's dissect that a little bit further, because when we talk about fats, there are 2 types of fats out there. There's actually 3, but we need to really focus on 2. So number 2 under fats, I'm basically going to write there are 2 types of fats. You have saturated and unsaturated. We're going to talk about what that means. So let's go into saturated fats first. So let me define what a saturated fat is, and we'll draw it out so it makes sense to you. It's actually, it's like puzzle pieces. Once you put them together, it's going to make perfect sense. So what a saturated fat is, it's a triglyceride. And remember, you have 3 fatty acid chains on your triglyceride. But in this triglyceride, every fatty acid within the hydrocarbons within the fatty acid chains, they're only made of single bonded carbons. So there's only a single bond between each carbon in the fatty acid chain. And that's huge because that goes to the structure, which ultimately leads to the function again. So a saturated fat is a triglyceride that has only single bond carbons. Single carbon-carbon bonds, if you will. Single carbon-carbon bonds in the fatty acid chains. It's a big deal because it, again, structure, function. So having only single carbon-carbon bonds in the fatty acid chain does something really neat to how it interacts with other triglycerides that are also saturated. So to draw one, and I'm just going to kind of quickly draw one and show you why. Remember, you have your ester linkage between the 2. Then you have your fatty acid chain, and I'm just not even counting right here. I'm sure it's long enough. And remember, every point is a carbon. Every point is a carbon, and if I have a carbon here, I have a hydrogen and a hydrogen. And so it goes hydrogen, 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 hydrogen. So you can imagine, if I were to keep drawing this, you would just see nothing but hydrogen surrounding every single carbon. You might say that every carbon is saturated with hydrogens, and they are. So if every carbon within the chain is surrounded, it's either holding another carbon, but if it's not holding a carbon, it's surrounded by hydrogens, and you have 2 hydrogens on the carbons in the middle, and then this one would have the 3 at the very end. Every carbon is saturated in hydrogen. So if I were to draw that in a shorthand, you're going to love me for this one. Here's the shorthand version of what a triglyceride looks like. You literally just draw a stick to represent the glycerol, and then you draw fatty acid chains coming off the stick. Okay, so these 2 things are the same thing when it comes to biology shorthand, if you will. So I want you to keep that picture in mind, because if I have a saturated fat, meaning I have nothing but single bonds between every single carbon inside my fatty acid chains, all 3 of my fatty acid chains, I have to have single bonds throughout the whole thing. Here's what can happen. I have my glycerol, and I'm going to have my fatty acid chain, and another fatty acid chain, and another fatty acid chain to get my triglyceride. Does that look like I could actually stack that on top of another one? I actually can. So if I have another triglyceride, I could stack it and imagine how many more I can stack on itself. It's almost like Lego pieces. You could just keep stacking themselves up to make a huge tower of it. And that ability to stack is huge. If it was only single bonds in here, you can actually start stacking these things. So what I want you to know for saturated fats, and I'll put it over here, under saturated fats, because of the single bonds within the fatty acid chain, it allows the saturated fats, the saturated triglycerides, to stack upon themselves. And this is why saturated fats are solid at room temperature. Pretty neat, huh? Because if they're stacked, you can imagine if I'm stacked together, if I'm a saturated triglyceride and I put a whole bunch of me next to each other, we really can't move around too much. So that creates the solid consistency you get at room temperature. When you think of saturated fats, I want you to think of animal-based fats. Butter, lard, bacon grease. Ever make bacon? And then it's liquid, of course, when it's being heated, but if you let that pan get to room temperature, all that bacon grease gets solid. That's because animal fat is saturated fat. That's just the nature of animal fat, because we use this as storage for energy. And there's tons of hydrogen and carbon on here, and those are where we also get energy sources from. So, due to the single bonds in the saturated fat, saturated fats can stack upon each other and are therefore solid at room temperature. Can stack and are solid at room temp. They're solid at room temperature. That's what's really, really interesting. Okay? That's what I want you to know about saturated fats. Now let's talk about unsaturated fats. Little b. Unsaturated fats. You're going to notice in biology we have like a yin-yang situation going on here. If you have a situation saying one thing, you're going to have a situation saying kind of the opposite thing as well. So unsaturated fats kind of fall into that criteria. So this will be little b, unsaturated fats. So I want you to go back in time with me. So if a saturated fat is a fat made with single carbon bonds in the fatty acid chain, you can almost imagine that an unsaturated fat, we were focusing on the bonds so much, so an unsaturated fat must have, or must not, must be made of something else. They actually have double bonds within their fatty acid chains. So as long as you have one or more carbon-carbon double bonds in any one of the three fatty acid chains, by definition, you have an unsaturated fat. So, unsaturated fats are triglycerides made of fatty acid chains with one or more carbon-carbon double bonds. And remember, there's 3 fatty acid chains for every triglyceride. Just one of the fatty acid chains has to have a carbon-carbon double bond. That's it. You could have them in all 3, but all you need is one. So here's what goes on when you have a carbon-carbon double bond in your fatty acid chain. I'll do a little bit more detail on this one. I'll keep this one saturated. I'll keep this one saturated. And then what I'll do is I'll make my double bond there. Do you notice how that changes how the fatty acid chains lie, if you will? So these ones are saturated, so they're straight across. They just make this nice, pretty long chains, these hydrocarbon chains. This double bond puts a kink in the situation. And now I'm not saturated with hydrogen anymore, because if I'll put the carbons in place here so you can see. So if the carbons are like that, I already have 2, 4, 6 electrons there, so I can only hold one hydrogen here and one hydrogen here. Whereas every other carbon can hold 2 hydrogens. So they're not saturated anymore. They're not completely unsaturated, there's still hydrogens there, but they're nowhere near the saturation point that the other ones are. And most importantly, that double bond makes a kink inside the hydrocarbon fatty acid chain. And that kink does completely different structures in there. So what we need to know is that that loses its ability to stack. I want you to imagine if you and a whole bunch of people next to you, if you're standing straight next to each other, you could stack together pretty closely. That would be a saturated fat. But if you decided to kink your leg out or to kink your arm out, you can't stack together as closely as you'd like to. There will be space between you. And so that ability to create that structure, that kinked structure, leads to a different function. That's the whole point of biology. So what you need to know for unsaturated fats, I'll put it over here, is the double bond in the fatty acid chain creates what we're going to call a kink that prevents stacking. So therefore, you can imagine what that would look like at room temperature. If I could stack together at room temperature, I'm solid. If I can't stack together at room temperature, I'm going to be liquid at room temperature. So therefore, it's liquid at room temperature. Now I want you to think that unsaturated fats, the main source we get for unsaturated fats are plant-based. Think olive oil, peanut oil, sesame oil, oh goodness, any oil you could think of. Oils are usually plant-based. And we're going to talk a little bit more about coconut oil later, because coconut oil is a little bit different. If you ever use coconut oil for your cooking, you're going to see that it kind of hovers between a solid and a liquid state. It has a very low melting point. So it has a little bit different structure to it, which lends to a different function as well. But the majority of plant-based oils are liquid at room temperature because they are unsaturated fats. Now you can have, this double bond can be anywhere along, you can have more than one of these in your unsaturated fat as well. I'm drawing you a very simple example of what an unsaturated fat looks like. Now this kind of unsaturated fat, this is called a cis bond. Like this is a cis double bond, CIS. You don't need to know this unless you decide to go crazy organic chemistry on it, but it does do a little something different. So when it's cis, you have your hydrocarbon chains both facing in the same direction coming off of the carbons. They're both going in the downward direction and the hydrogens are up. Now, you might have heard, if you're ever interested in your diets, how trans fats are bad for you and how we need to cut out all the trans fats in our diet. It's actually not a bad idea. It's never bad to lower the fat content in your diet. However, what trans fats do is they change the kink to go a little bit up this way so they can stack a little bit better. And so a lot of times they'll partially hydrogenate and do different things to fats to make them less oily, if you will. think of your typical over-the-counter peanut butter that you can buy, and I'm a peanut butter fan, but a lot of times back in the day they used to make peanut butter partially hydrogenated, so you would get this trans fat action going, so the kink wouldn't be nearly as severe, and you would get some stacking going on. Compare that to organic peanut butter that you just literally crush up the peanuts. You always see this peanut oil layer on top. That's because you're seeing the unsaturated fats rise to the surface. So that's what you need to know for the different kinds of fats. We got saturated, we got unsaturated. The difference in the fatty acid chain makes all the difference in the structure and the function. So obviously saturated fats, animal-based fat, they could stack. They're solid at room temperature. Once you get to the plant-based fats, those are unsaturated fats, and they cannot stack at room temperature because of that double bond creates a kink. All right, we're going to come back and we're going to learn about phospholipids as our next lipid in line, and then follow that with steroids. So see you soon.